Hello everyone, welcome back to our channel. Today we'll start a new topic called as a space force. Most of the students find this chapter very difficult because it consists of vector calculations, x, y, z, three-dimensional coordinates. So most of the students skip this chapter, but I will promise that I will make this chapter so easy that you can solve any question which will be asked in the final exam. So we'll start with first part of this chapter, that is how to represent a given force in the vector form. So first we'll understand how three-dimensional coordinate system works. So it consists of three axes. So the first horizontal axis is called as x-axis, vertical axis is called as a y, and the last axis is called as a z-axis. So in this way these three axes are mutually perpendicular to each other. So always remember the position of x, y and z axis. Now we'll see how to convert the given force into a vector form. So for that again we should have the understanding of the axis. So O is the origin, this is the x-axis, vertical is y-axis, and the third axis is called as the z-axis, and this is the given force. So this force starts from this point and goes to this direction. So it is depends on the direction of the force. If the force is like this depending on arrow, so this is the initial point and this is the final point. If the force is like this is the initial point and this is the final point. So in this way we can represent it. Now the magnitude of this force is capital F. We will indicate 2 points. First point is here, this is the initial point, and this is the final point on the force. So first point is A. The coordinates of first points are indicated by x1, y1 and z1, and coordinates of the second point, that is B, is equal to x2, y2 and z2. In this way we have to identify 2 points to represent any force. The first point is the initial point and its coordinates are x1, y1, z1. Second point is the final point, it is equal to x2, y2 and z2. Now we'll see how to convert this force into vector form. Basic vector form of any force is equal to fxi plus fyj plus fzk, where I is related to the x-axis, j is related to the y-axis and k is related to the z-axis. Now we'll find the value of fx. Fx is nothing but the magnitude of the force into x2 minus x1 divided by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So this formula will give you the value of fx. Similarly, fy can be calculated by using the formula f into y2 minus y1 divided by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. And the last one, fz part is equal to f into z2 minus z1 divided by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. If you observe this formula carefully, it consists of the same components like force into 1 divided by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. The only difference is that for fx we multiply this formula by x2 minus x1, for fy we multiply this bracket by y2 minus y1, and for fz we multiply this bracket by z2 minus z1. So in this way we can easily remember the formula to convert any force into the vector form. Now we'll see one example. A force of 100 kN acts parallel to the positive x-axis. So only this information is given, and this is our coordinate system, and this is our force which is parallel to your x-axis. Now it doesn't have any other coordinate. So we can represent this force as 100 kN is equal to, the basic formula is F bar is equal to Fxi plus Fyj plus Fzk. So instead of this we can represent this force as 100I because it is only parallel to the x-axis. So with this representation we can represent a given force. We'll see the second example. A force of 50 kN acts parallel to the negative z-axis. So this is our z-axis and this is the positive direction. So opposite is a negative direction. So your force is pointed in the negative direction of the z-axis. Now out of I, j, k, k is related to the z-axis. So here only k components come with the minus 50 sign. So the vector form is like this. So here the value of f bar will be minus 50k because it is parallel to the z axis. Similarly, we can find the force which is parallel to the y axis. Suppose it is in the direction of y axis, so its value will be magnitude into j component. Now let's see slightly difficult example. Question number 3. A force of 200 kN passes through the point A030 and B505. So two points and their coordinates are given in this example. The magnitude of the force is 200 kN. Initial point A is equal to x1, y1, z1 and the coordinates are B are also given in the question. So the vector form for the given force will be F bar is equal to Fxi plus Fyj plus Fzk. So this is the second point B. Its coordinates are x2, y2, z2. Now I will first write down what are the values of x1, y1, z1 and x2, y2, z2. The value of x1, y1, z1 are the coordinates of A, 0, 3, 0. So the value of x1 is 0. The value of x2 is 5. Then the value of y1 is a y coordinate of point A, so it is 3, so it is written here. The value of z1 is the z coordinate of point A, so it is 0, so it is written here. Then the y2 is the y coordinate of point B, it is 0, and z2 is the z coordinate of point B, it is equal to 4. So in this way you have to write the values of x1, y1, z1 and x2, y2, z2. Follow this step to avoid any mistake. If you directly jump into the direct formula, you might make a mistake. That's why write it in the given sequence only. Now we'll find out what is the value of x2 minus x1. So subtract x2 from x1. So it is 5 minus 0 is equal to 5. Next one, y2 minus y1. So it is 0 minus 3, it is equal to minus 3. And at the end, z2 minus z1. So it is 4 minus 0, it is equal to 4. So calculate all the values. Don't make mistake in the calculation. At the end, we required the square root of x2 minus x1 square plus y2 minus y1 square and z2 minus z1 square. So that is the fourth point. Now put the values or take the values from 1, 2, 3. Put it here in a square root. 5 square minus 3 square 4 square. Find the answer. The answer is 7.071. So in this way calculate point 1, 2, 3 before starting the actual solution. So as we have got all the values, we can put those values in the given vector form. So the value of fx is equal to f into x2 minus x1 divided by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So we have reduced this complex calculation into simple calculation as we have already calculated the value of x2 minus x1 and the square root. Here we'll put the value. The value of f magnitude is given, it is 200 kilonewton into x2 minus x1 5 divided by square root of all those things, it is 7.7071. Put the value here, find the value. So the answer is 141.42 I kilonewton. Why I? Because it is related to the x-axis. That's why I component is shown here. Then Fy. Forget the complex calculation. What we will do? We'll multiply the magnitude with the y2 minus y1 divided by 7.7071. So 200 into minus 3 divided by 7.7071. The answer is minus 84.85 J kilonewton, where J represents the y coordinate. Then Fz. For the Fz, we'll multiply the magnitude 200 Newton into 4 divided by 7.7071. The answer is 113.14 K kilonewton. So if you directly substitute in this formula, there is a high possibility that you will make a mistake. That's why follow the steps to find out the vector form of the given equation. So after calculation of fx, fy and fz, we'll write the vector form for the given equation. So the vector form is f bar is equal to fxi plus fyj plus fzk. Here just put the value of fx, fy and fz. The value of f a b, because initial point is a and final point is b, so we can represent it as f a b is equal to 141.42 I minus 84.85j plus 113.14k. It is a vector form for the given force system. So in this way, we can easily calculate the vector form for any three-dimensional coordinate system. You can try with different example. If you have any doubt in this lecture, you can comment it in the comment box. I am happy to help you. If you find this video helpful, you can like this video, share this video, and please subscribe to our channel. Thank you very much.